that what you're going to be teaching about?
Yep.
Oh, so you got to know all the answers?
Yep. I have a little paper right here with all my answers on it.
So you can tell them the answers?
I can tell them the answers
when you're finished.
When we're finished.
When we are?
We are streaming. See if everybody's here. Coming in for algebra. Let's see this. Say hi.
Hi. Are we doing times?
What we are going to, no, we are not doing times. We are going to teach them how to do exponential functions.
What do they look like?
They'll see, whichever ones do. Oh, Isaiah said hi.
Hi.
Alrighty guys, so today we have our first lesson, exponential functions. Jolie is going to be our little helper. She's going to watch as we do it. Can you close the door, Jolie? Okay. So, hopefully you guys have your calculators with you. If you don't, I know that there is an app on your phones that you can download the TI-83 calculator for. Hopefully you also have the graphing exponential functions packet. If you don't, remember you can go to www.cimath.com, go to the algebra page, and then print out graphing exponential functions packet. Hi, Tiffany. Tiffany, this is algebra. Algebra 2 and trig is later on this afternoon. Okay, so this is just going to be the algebra 1 lesson. Okay. All right, so graphing exponential functions. So if you see in example 1, it says the function y equals 3 to the x. Well, that is what is an exponential function. A little bit of a learning curve with this pen right here, so kind of stick with me. So it's exponential functions. And that's because the exponent is a power. The exponent is a power. So if you look, no, that's okay. So if you look in this first example here, it says y equals 3 to the x. So that's how I know that this one's an exponential function. So as just a quick recap, we know that our parent functions, if you have a y equals x, where the x is like that, we know that that's going to be a linear function. Then recently we just learned that we have x squared, okay, so linear, that's a line, and x squared, that's a quadratic function, and that kind of has that parabolic shape like this. And then what we're going to learn today is this 3 to the x, which is an exponential function. So here we go, we have our first example here. So if you have your calculators, go into the y1, go into y equals, and then put 3 to the x power. And remember, depending on which calculator you have, whether it's a newer one or older one, you're going to hit 3, then you're going to hit this button right here, which is above the division, and then x. And then you can go ahead and hit graph. So if you did that, then you would notice your first exponential function, and it's going to look something like this. And we'll fix that up in a second. That is what we're going to look to graph. Now, for those that don't have a calculator or have access to like a regular scientific calculator, this is kind of how you do the work if you were going to substitute it in. And then if you have the graphing calculator, you don't need this part. So this part would just be saying 3 to the negative 2, which would be 3 over the positive 2, and 3 squared is 9. So this is kind of 1 over 9. Now, when we're graphing these, we know that we're not going to be graphing a 1 over 27 or a 1/9. So these numbers in your calculator or on your table, if you go over to the table, they're going to be fractions. So over here, you're going to have like a 0.037037 number. So if I'm going to write that as a point, that's going to be negative 3, comma 0.037. And then we'll continue down the line. So that at negative 2, you're going to have 0.1111 repeating. So that's point negative 2, comma 0.1 repeating. At negative 1, it's going to be 0.3 repeating. So that's going to be negative 1, comma 0.3. And then at 0, you're going to see 1. At 1, you'll see 3. 9, and so if you guys have any questions as we're going through, make sure you ask those questions. Try to keep the comments to a minimum so that I can kind of see what it is that people are asking when they have real questions. And at the end, I'll answer any other regular questions you guys want. All right, so here we go. Let's graph these three. So at -3, we're going to go right here. Now, you're not going to get exactly 0.037, so you just keep it above that x-axis a little bit. At -2, you'll have 0.1. At 0.1, you'll have 0.3. At -1, you'll have 0.3. At 0, it'll be 1. At 1, it's 3. At 2, it's 9. And then at 27, well, we can't graph 27, so we won't worry about that. And then if we carefully connect those dots, we're going to go like this. Now, here's the tricky part. If you have your calculator and you're looking at the table, you're going to notice that numbers just keep getting smaller and smaller and smaller. They're never actually going to become 0. They're always going to kind of stay above 0 on our positive space. Okay? And we're going to explain why that happens there. So if you're graphing this and then all of a sudden you go and you do this, you're wrong. Okay? I'm going to tell you why in a second. So just make sure that when you're graphing this, you're not going below the x-axis. So then here we go here. So since the y values are increasing as the x values are increasing, this is called an exponential growth. Okay, so again, whenever we read graphs, we read from left to right, so we can see as we go, it's growing and it's going up. Okay, so now in the exponential function y equals 3 to the x, the y values can never equal or be less than 0. Can you fix the light so it's not blinking? Okay, so like I said before, it'll just keep getting closer and closer, but it'll never actually hit the 0, so you're never actually going to become 0. Okay. Next one, definition 2. So since the y values can never equal 0 in this function, this is called a horizontal asymptote. And that's at y equals 0. So if you ever go up to trig, you'll understand the asymptotes a little bit more. But for what we're understanding right now, just know that you're going to just keep getting closer and closer and closer to the x, but you're never actually going to hit it. Okay? Yeah. I don't have it set up like that. This is Cornell. I'm going too fast. All right, so if I'm going too fast, tell me what it is that you want to know.
Rona, you need a new screen name. That's not appropriate.
Why can't it equal 0? That's a good question. We're going to get to that a little bit later and what's going to happen when we do have a 0 and why we'll never hit it. Let's put it this way. Okay, let's add a new page. Let's take the number 10. Okay, so let's say we're looking at the function like 1/2. If I took half of 10, I'm going to be at 5. If I took half of 5, I would be at 2.5. Take half at 2.5, you're at 1.25. I can keep taking half of something. So if I wanted to, say, reach this spot here, by only taking half, so half of that, that's right here. Half of that, that'll be right here. You'll always be able to continue to take half. You'll never actually reach that spot. So that's why you're never going to be 0.
I can't.
Okay, so that's why you're never going to equal 0. Okay, so from the graphing section, does anybody have any questions on the graphing spot right here? Now there's a delay, so I have to wait a minute to make sure.
I want to know where you are.
Mm-hmm.
Hi, everybody.
You're right there.
Oh. Hi, Kim. You should get Remind. I have Remind.
This is my lessons right now.
I know, but they're talking to me. I do.
All right, we'll do that at the end because other people are going to watch.
Bye, everybody. Have fun with your math.
All right, so I don't really see any questions for that. Does anybody have any questions on here? So for 3 to the x, we call that an exponential growth, and then we learned that it's never going to actually be 0. Okay, you don't have to get too caught up on the asymptote part, but that was just understanding that you can never actually be 0. All right, so now let's look at domain and range. So I'm just going to keep asking questions. So you kind of just answer them as we go. You don't have to type them in. So if I wanted to know the domain of this function, remember again, we're leading from left to right. That's the question we're doing. We put it in our calculator before. I'll get back to why it can't be 0 again in a minute. Okay, so domain. If I'm reading from left to right, okay, if we're reading from left to right, he hits here, he sees an arrow, so you know you're going from negative infinity. When he gets over to here, he looks up, he sees another arrow, so your domain is going to go from negative infinity to positive infinity. No, there's not a formula for this. All you have to do is put it into your calculator. We're going to be doing another one, so just kind of stick with this one a little bit, and then when we do the next one, you'll understand a little bit more. Okay, so you're going from negative infinity to positive infinity, and again, domain talks about x. So when you're graphing y equals, you can put any number you want in the x, and you'll be able to get an answer. So like we did before, if you put a 2, we got a 9. If I picked a negative 2, then we had a 0.11111 repeating. All right, so now the range. Okay, this is when it gets a little bit tricky. So remember, range is the y-axis. So what we're going to do is we're going to go from the bottom up. So as I'm going up, okay, he sees the graph here, right? Now, where is he sitting? We just kind of talked about that you can't be 0. You can't be 0, because remember, if you wanted to take half of a number, you'll always be able to get half of a number. So you'll never actually reach the 0. So as he climbs up, he could be all y values above that. So what does that mean? That means that the y values, or your range, can be any number that is greater than 0. Okay, you cannot be 0, so just be any y value greater than 0. So that's our exponential growth. So if you were a little lost or a lot lost, we'll probably be able to find you on the next question here, which is now graphing this exponential function. So again, if you have your calculator, you want to put this into your calculator. So if you go to your calculator, you go to y. Remember, we like to put fractions into our parentheses. So in our y1 on our calculator, we're doing 1 divided by 3. So now it's an exponent of an x, so you're going to hit that button above the division, and then you're going to hit x. So that's what it should look like in your y1. Now, if you have the newer calculator, it would look more like this. Now, when you hit graph, you'll notice that the graph is basically the same numbers, but we're backwards. Okay, so if you go to your table now on your calculator, then what you're going to do is you're going to notice, I'm going too fast. All right, so, and everyone keeps asking me, I don't have a printer, what do I do? Well, then you can pull it up on your phone, or take out a piece of paper and copy it down. You're not copying down a million things, you're copying this, and you're going to make a table, and then you can sketch a graph. It doesn't have to be perfect. You should have that page if you went on CI Math and printed it out. You would have it on from there. All right, so it's in your calculator. Yes, I'll slow down. So you put this into your calculator. It's in your y1. Then what you can do is you're going to hit graph, and then you're going to go to the table. Now when you go to the table, you're going to copy down this table. And if you're just writing this on a piece of paper, then just write a regular table. So at -3, it's 27. At -2, it's 9. At -1, it's 3. At 0, it's 1. At 1, it's 0.33333, repeating. At 2, it was 0.1, repeating. And at 3, it's that 0.037 now. Okay? Okay, so make sure you copy that table down there. After you have the table, we're going to go ahead and graph. 27's off, so I don't have to worry about graphing that one that says 27. So I'll sketch it. -2 with 9. -1 goes with 3. At 0, we had 1. Now, from this point here, you're not going to graph them perfect. All you have to do, yes, I am not only getting, I'm waiting for the school to email me back so that the calculator that we have on the smartboard, I'll be able to have on here. Otherwise, those online calculators don't really work too well when I'm trying to screencast it. So sketch that graph there. So one of the things you might notice if you have it on the same page or you're sketching it out is it's very similar to the last one. Okay, so don't write, just watch. On the last question we just did, we graphed y equals 3 to the x power. We graphed y equals 3 to the x power. Now when we graphed y equals 3 to the x power, it was literally the same exact numbers, it was just backwards. So this is what 3 to the x power looked like. It went like this, and then it went up. Okay, this was the question that we just did before. So if you notice, it's just the same exact thing, just kind of reflected over the y-axis. So let's learn how it's a little bit different. So since the y values are now decreasing, the last one, our y values were going up, now they're going down. We're going to call this one an exponential decay. So now we have an exponential decay. Then it wants to know, is there an asymptote? Okay, remember the asymptote is that line or that you can get closer and closer to never actually hit or get to. And it's the same concept here. So if you look at this, then again, you're getting closer and closer and closer to the 0, but you're never actually going to hit it. So it's yes, and where is it? That's when y was equal to 0. So that's, again, that's the x-axis here. Why is it a decay? We're going to do that one right now. So if you, again, when we read graphs, we read from left to right. So if I'm reading from left to right, the first spot I am is here. So what happens to the graph as I move to the right? The graph is going down. That's why it's a decay. In this one here, again, reading from left to right, you're starting down here, and as I go to the right, this graph is going up. That's how I know I have an exponential growth. Okay, domain and range, very similar. Okay, so as we read, I'm just going to sketch here so we don't have to keep going up and down. So it looks like this. So as I read from left to right, I'm going this way. We start here, we're at an arrow, so we know that we're going to continue going in this direction, which is the negative direction. So that's negative infinity. And then I continue to go, and then again, we're continuing in the positive direction, so that's going to be the positive infinity. So x can be all real numbers. I don't care what x value I pick. Thanks, Ms. Holden. Now we do range. Same thing, from the bottom up. So when we get to this spot here at that 0, is the graph actually at the 0 mark? Well, no, because the graph can't hit 0. But it continues, it can be any value on the y. So it's going to be y is greater than 0. So any value greater than 0, you will be able to find on your table, and that's kind of what you're saying there on the range. Okay, so that's really all of the notes. So now I'm going to kind of go through different examples to kind of show you how you're going to know if something's a growth, how if something is a decay, and then how we can use those in different formulas. So if you have the notes, go to the next page. If you don't have the notes and you have a printer, go to cimath.com, go to the algebra section and print it out. If you don't, okay, try to get maybe 2 phones, one for the stream and one for the notes, or you can just follow along if you have paper with you and just kind of copy them down as we go. All right, so now here we have a couple of different examples. Okay, all I want to know is it a growth or is it a decay? That's it. Okay, all I want to know is it a growth or is it a decay? So the easiest thing to do, again, just put it into your calculator and look at it. So if I'm going to show you what the graphs look like, all growths will look like this. Okay, it'll start on the low and it'll kind of continue up. All decays will look like this. So if you're using your calculator, we'll put it in, look at it, and then just tell me growth or decay. Okay, so I'll just go through them and we'll say whether or not they are growths or decays, and then we'll kind of experiment and see how we could do it. Well, if I didn't have the calculator. So I have 1 over 4x. So if you put again in your y1, if you're using a calculator, you're going to do 1 divided by 4 to the x power, and then you hit graph. And then this one's going to be a decay. 2 to the x power. Okay, so if you're in your y1, it's going to be 2, hit that button, x. Okay, if you forget this, it's going to graph a line, so you're not going to be able to do it. And this one's going to be a growth. When you go to graph 1 to the x, it's going to look like this. Okay, when you graph 1 to the x, it's going to look like this. So think about these for a second. If I wanted to know what 2 squared is, that's just doing 2 times 2, 4. So if I'm taking 1 to any number, you're just doing 1 times 1 times 1 times 1, right? And that's just going to give you 1. So nothing's going to happen when your base is a 1. Decay means you're going down. Okay, here's decay. Here's growth. The question was, what does decay mean? So just the direction that the graph is going, or the values in the y are going. So if it's growing, it's going up. If you're decaying, you're going down. Okay, 5 to the x, that's going to be a growth. 0 to the x, go back to this over here. Okay, what's 0 times 0? What's 0 times 0 times 0 times 0? Okay, not going to have anything to there. When you get to the negative space, you're going to have some errors. And then this last one, again, calculator. 2 divided by 3 to the x power. That one's going to be a decay. Okay, so these questions here, that's going to be neither. So these questions here are all they're asking you is, are you a growth or are you a decay? If you feel like I'm going way, way too fast, remember it does go back on, so you can go back and watch it again on what you're getting lost on. Am I a growth or am I a decay? If I wanted to know what's 1 divided by 4, that's 0.25. 2 is 2. I'm going to tell you how I know. 5 to the x, or here, if I did 2 divided by 3, that's going to be 0.6 repeating to the x power. Okay, so how do I know, without a calculator, if it's a growth or if it's a decay? If I look at the number inside, or the base, okay, the base to the exponent, if you think about this one and the ones we did before, which was 1/3 to the x and 3 to the x, all numbers between 0 and 1, 0.25, 0.3 repeating, 0.6 repeating, at 0 point a number, those will always be decays. Okay? Any number between 0 and 1, forget negatives, we know it's not 0, we know it's not 1, any number between 0 and 1 is going to be a decay. Any number that's greater than 1, 3, 2, 5, we know that's going to be a growth. So if I'm just looking at an equation, I will know if I'm a growth or decay just by looking at the base number. So again, between 0 and 1, and I'm going to give you these notes, you're going to be a decay, and then greater than 1, you know you're going to be a growth. So right here, what we have here is just practice problems. Okay, so right here on the next page, we have practice problems. So we'll be able to kind of try to hopefully answer any final questions that we have. So before I start doing these, does anybody have any questions on these questions back here? How do I know if something's a growth? How do I know something's a decay? How do I put it in my calculator? Those are really all the things that we've gone over so far that you have to know. All right, well, let's go through these questions. What is decay again? Decay means you're going down, okay? So decay means you're going down. The numbers, if you put them in the calculator and you look at the y, those y numbers would be going from, say, 27 to 9 to 3 to 0.1 to 0.3 to 0.1. They're just going to keep going down. That's all decay means, is decreased. So decay, think decreased to go down, okay? So let's just do some more practice. So if I'm going to do this one, just by looking at it, do you know if it's a growth or a decay? Remember, it's this number that will tell you if it's a growth or a decay. So is that number between 0 and 1, or is that number greater than 1? Well, 1 divided by 2 is 0.5, so that means I know that this one's a decay. And then again, just put it into your calculator. So if you put it into your calculator, 1 divided by 2 to the x. No, not really. The parentheses don't really matter, but it's a good habit because sometimes it will matter. Yes, growth is going up. Okay, so it's just good habit. If you have a fraction, put it in parentheses. Most of the time it'll be fine, but you don't want to get tripped up on the 1 or 2 times that it does matter. All right, good. All right, so now if you have a calculator, then you did a couple of numbers that are in the decimal space and pick a couple of numbers that are in your integer space. So here, again, it was easier if I went from -3, -2, -1, 0, 1, 2, and 3. So at -3, it was 8. At -2, it's 4. At -1, it's 2, and then it goes 1, 0.5, 0.25, and then here is 0.01. It's just an ugly decimal, so that does not repeat. I should put the line. 0.0156. Not super important. We just know that these numbers are going to keep getting smaller and smaller and smaller, but they're never going to be 0. That's the most important thing that we take from today, is that you're not going to hit the x-axis. You're not going to be 0. When we plug in the problem into our calculator. Okay. So now if you're going to graph it, again, in this area, you're not going to have to go crazy about being in the perfect spot. So at -3, you're 8. At -2, you're at 4. At -1, 2. And then here we just know it's just going to keep getting closer. And then we sketch it. Okay, remember, don't cross over. If you cross over, you're wrong. And there it is. There's the graph. Now, we already talked about it. We know that this one's a decay because of the 1/2. Now, down there, they're asking domain and range. I'll write it up here. So if I am doing domain, I'm reading from left to right. So here he starts. So this is going to continue going to -infinity. When he gets over here, he's standing at 8, but there's an arrow, so he's going to continue to going to +infinity. So your domain, again, it could be any number in the x, all real numbers, goes from -infinity to +infinity. Now let's do the range. Okay, we start on the bottom, we work our way up. We start to see the graph down here. Are we at 0? Can we be 0? Is the range starting at 0? That's your question. If you look in your calculator, you can hit the down button or the down button and look at any number. You can go all the way to 5,000 in the x. You're never actually going to see 0. So it's just going to be all numbers that are greater than 0, and that's your range. And I think we're done with that. Yep, and we're all done with graphing 1/2 to the x power. Okay, so when we're done with that one, we'll graph his reflection, and we're going to graph 2 to the x power. Hopefully now you're starting to understand it a little bit more. All right, so here we go. So 2 to the x power. Is it a growth or is it a decay? Okay, we look at the base. The base is 2. He's going to tell me if he's a growth or decay. If that number is a decimal between 0 and 1, you know you're a decay. If it's bigger than it, you know that if you're bigger than 1, you know you're a growth. So 2 is a number bigger than 1, so we know that this question automatically is going to be a growth. All you have to do is put 2 to the x power into your calculator. Okay, 2 to the x power into your calculator. Okay. Whoa. Yes, all the whole packet's on CI Math. We go on our calculator, we copy down the best table. This one's very similar to that other one. Start at 0.0156. Then you're going to go to 0.25. At -1, you're going to be 0.5. At 0, 1. Then 2, then 4, and then 8. At 2, and then we can go ahead and graph it. Remember, in this area down here, you don't have to get too crazy. Just make sure you're a little bit better. 1, 2, 2, 4, 3, 8. So if you don't have these notes printed yet, just take the notes on a piece of paper and just sketch this, okay? And then there you go. And then again, how do I know it's a growth? Just by looking at a graph, because again, we're reading from left to right, and this graph is going up. Domain and range is going to stay the same as all the other ones. Domain can be all real numbers from -infinity to positive infinity. Your range can be all numbers that are greater than 0. Yes, I'm just graphing what I got on the table. Okay, so all you have to be able to do is be able to put these into your calculator. And again, if you don't have a calculator, go online, take your phone, whatever you need to do, and get the calculator from online. Remember, you could also go back and play back the video and then kind of work along with me again using your calculator, pause it, play it, whatever you need to know. All right, so here what we kind of already looked at this one. We'll just kind of save some time here. We already talked about what happens when it's 1. Remember, that base is not going to do anything at 1. It's going to be neither a growth nor a decay. It's just going to be a kind of a straight line right across here. Neither a growth nor a decay. Okay, so just kind of take a look at that. Domain, same thing. X can be any numbers there. Range. The only values here that you have in your y is 1. So it's just y equals 1. So 1 to the x is neither a growth or a decay. Okay, it's neither a growth nor a decay. There it is. You're done. Okay, and then the last thing I have for us that we'll do let's do this then instead, because we're already at 35 minutes. You do these questions here, okay, for the next live for tomorrow. Okay, you practice doing these questions here. All these questions here, we'll do some more notes tomorrow. All these questions here are just asking you to plug it into your calculator. 5 to the x for x equals 4. All they want you to do is take your calculator and put 5 to the 4th power. Okay, here it just says 3 times 4, and then it says to the -3 power. They're just asking, well, what's the value when you plug it in? And then here they're asking for domain and range. All they're doing is putting this again into your calculator, into your y1, and they're giving you the domain of -2, -1, 0, 1, and 2, and they're asking, well, what's the range? So that's what you're going to practice. This way you have some things to do on your own, and it'll give you time to either print this out, go back, play it back. Then tomorrow we can go over it. You can download a calculator and then we can finish going over and reviewing the rest of this tomorrow. Does anybody have any questions on graphing exponential functions? Have to wait for the delay to go through. Okay, because I want to try to keep the videos under 30 minutes. Lewis, if you're just going to sit there and comment and not do work, then I will block you out. All right. Well, hope you guys enjoyed the video. Hit the subscribe button down below, hit the like button, and everybody have a safe